أعوذ بالله من الشيطان الرجيم أفاق كل ذي علم عليم صدق الله العظيم. بسم الله الرحمن الرحيم. This is our lab about basic concepts in probability. In the first sheet of this Excel lesson, we have some definitions about probability. The random experiment means that we have more than one possible result and we don't know which of them will happen first. The sample space is the set of all possible results that may happen in any experiment. The basic outcome is any outcome that may be a result to the experiment, and the event is any subset of basic outcomes or combination of these basic outcomes or possible results, such as getting greater than B in exam. So if the event is getting greater than B in the exam result, that means B and B plus and A plus. If the event, for example, is getting C, that means only C. Mutually exclusive, that if an event A and B have no common results or basic outcomes, then they are mutually exclusive. The intersection of events, if A and B are events, then A intersection B equals all possible results or basic outcomes that belong to both of them. Union, that if A and B are events, then A union B equals all possible results or basic outcomes that belong to at least one of them. So it is not a shared area between two events. It is the combination. Now we are getting the result. You can say that all the possible results that may happen in here and here, or at least one of them. The complement of event, that if an event or if A event is an event, then A complement is all possible results that are not in A and it is in the sample space. For example, if the event is passing an exam, then the A event complement is not passing this exam. Let us see the classical probability. The idea is the probability of an event equals the number of possible results divided by the number of all results. For example, you have box contains 10 balls, 3 red, 3 green, white, 4 white. What is the probability of randomly selecting green ball, and what is the probability of selecting randomly white ball? For the solution, let A be the event of selecting green ball and B the event of selecting white ball. We have 10 balls, so the probability of A equals number of possible results for green ball, which is 3, divided by number of all possible results, which is 10. So the probability of A means 30% or 0.3. Similarly, for probability of B, it is number of results of white ball, which is 4, divided by total possible results, which is 10. So it is 4 divided by 10 equals 40%. Now, when we come to the permutation, in the classical probability, you see that we are talking about number of possible results. Sometimes getting this number, if there is different arrangements or order, is a huge task. Let us see how. The permutations is indicating what the number of possible arrangements for x items out of n total items. That is arranged by order. So the permutation of x out of n means the n factorial divided by n minus x factorial, while x factorial, 0 factorial equals 1. So for example, permutations of 3 items out of 10 total by order will be P 3 out of 10 equals 10 factorial divided by 10 minus 3 factorial equals 10 divided by 7 factorial. So 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 and so on till 1, that will equal 720. Means that there are 720 different possible ways to arrange 3 items out of total 10 by order. Okay, so this is an example. The ministry has a visit to one school and they decided to call 3 students randomly from the student council. The student council contains 5 members, so how many permutations are possible? Imagine that if they are going to call 3 students, then now consider that they will call first student, second student, third student. Okay? Now, in other order, they may call the second student, then first, then third. In another order, they may call the third and first, then second. So, there is more than one way to arrange. Imagine that you are having a paper and calling some names. You can call these names by different ways. That is the meaning of permutations. It is not just selecting this number and you don't care who is first. No, you are talking that this is how it might be like called, or these names are written in an email or so on. So the solution that the number of permutations is P 3 out of 5, that equals 5 factorial divided by 5 minus 3 factorial. That equals 5 factorial divided by 2 factorial equals 5 times 4 times 3 times 2 times 1 divided by 2 times 1 equals 60. And as you see, using Excel, you can directly get the result by applying equals, open bracket, 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Means that there are 60 possible ways to call 3 students randomly by order from the group of 5 students. Okay, let us prove this formula now. If we have these letters, 1, 2, 3, 4, 5 letters, and say that now we want to arrange these 2 letters out of 5. So as you see, we have AB, then BA, then AC, then CA, then AD, then DA, and so on. If we count all this number, you will see that we will get 20 possible arrangements. So let us now apply the formula of permutation, that is P 2 out of 5 equals 5 factorial divided by 5 minus 2 factorial equals 5 factorial divided by 3 factorial, that is finally 20, which is the same number. What about the combinations? The combinations is the same idea of permutations, but the difference is that in combinations we don't care about the arrangement or the order. So it is indicating the number of possible selections for X items out of N total items. Order is ignored, which is very important. You don't care about the order. For example, if you are selecting 3 persons in a group, then you are just selecting 3 persons and you don't care who is coming first. You don't care that these names are written or announced by this, then this, then this. You just put the 3 persons in a group and that's it. So it is a selection. It is not arrangement by order. The rule is for C, for X out of N, it is N factorial divided by X factorial multiplied by N S minus X factorial. It is the same rule for the permutation, but the difference is here we are using x factorial multiplied by this, sorry, divided by x factorial multiplied by n minus x factorial. So now let us look at this example. Possible combinations, selections of any order of 3 items out of 5 total. So the combinations of 3 out of 5 equals 5 factorial multiplied, divided by 3 factorial multiplied by 5 minus 3 factorial equals 5 factorial divided by 3 factorial multiplied by 2 factorial, that is finally equals 10. So that means that there are 10 different possible ways to select 3 items out of total 5, regardless the order. Okay, look at this example. Final competition has 10 candidates, 3 from group A, 5 from group B, and 2 from group C. For an interview by TV station, 3 candidates will be invited. Assuming that all candidates have the same chance to be selected, what is the probability of selecting 3 from group B? Note, the order is not required, only how many selections possible. So in this question, we need to get the combinations, not the permutations. Okay, see the solution now. The total possible number of combinations for selecting 3 candidates out of 10 is C, 3 out of 10 equals 10 factorial divided by 3 factorial multiplied by 10 minus 3 factorial, that is equals 10 factorial divided by 3 factorial multiplied by 7 factorial. And applying Excel formula, we can directly, as you see here, get the result of this one. And remember that when you divide these 2 groups divided by this multiplied by this, you have to put both of them in this big bracket to get a good or correct result. The result is 120. Then the total. Now, what is the total possible number of combinations to select 3 candidates from group B? Well, as you see here, group B has 5 members. So we want to select 3 out of 5. So the combination 3 out of 5 equals 5 factorial divided by 3 factorial multiplied by 5 minus 3 factorial. That equals what? That equals 10. So now, applying the classical probability concept, the probability of selecting 3 candidates from group B equals 10, which is the possible combinations of group B divided by 120 equals 8%. Look at example 2. Group of friends from 4 countries, 5 from UAE, 3 from Saudi Arabia, 3 from Algeria, and 2 from India. If they were in a trip and attended some event, part of this event was to participate in a game. And it was decided to select 4 participants from this group. The selection is randomly and everyone has equal chance to be selected. Now, what is the probability of selecting 1 from each country? So for this question now, we will assume that A is the event of selecting 1 candidate from each country. The total possible number of combinations for selecting 4 candidates from 13 candidates is C, 4 out of 13 equals 13 factorial divided by 4 factorial multiplied by 13 minus 4 factorial. That is finally equals, as you see here, using Excel, equals 715. Now we have to get the possible number of basic outcomes that is satisfying or achieving this combinations is not only one factor, it is four. It is as you see now, we have combination for UAE. What is the total possible number of combination to select one candidate from UAE is to select one out of three, because we have case mistyping, it is out of five. Okay, select one from five. So now the combination 1 out of 5 equals 5 factorial divided by 1 factorial multiplied by 5 minus 1 factorial finally equals what? Equals 5. Same way we are going to select 1 out of 3 for Saudi Arabia group, that will equal 3. We will select 1 out of 3 for Algeria group, that equals 3 also. For India, we will select 1 out of 2 equals 2. So now the number of possible combinations to achieve event A is the first selection, first possible number of selection for UAE multiplied by the possible number of selection for Saudi Arabia multiplied by possible number for selection in Algeria multiplied by possible number in India, so that equals 90. So now applying classical probability, the probability of A equals the total number of possible combinations for event A divided by total possible combinations for the whole experiment. That means 90 divided by 715 equals around 13%. If we want to prove this formula, we can look at these 6 colored cells, and now if we arrange these cells in a way that is only making a selection and doesn't repeat based on the arrangement or order, we will see that, for example, the first and second, first, third, first, fourth, first, fifth, first, sixth, then we don't come back. We, for example, this yellow and the black, then we don't repeat it like black and yellow. So the number of possible selections here is 15. And when we apply the formula, that is 2 out of 6, we will get also 15. Now let us look at the union rule in probability. If the events are mutually exclusive, means that there is no common basic outcomes between, then the probability of A union B equals the probability of A plus probability of B. So for example, if event A is the market rise first day and event B market rise second day, then A union B equals market rise at least one day, which is probability of A plus probability of B. Look at this example. Based on market study for a specific region, it shows that based on records data, the probability of making purchase at the beginning of month is 0.15, and the probability of making purchase the whole month is 0.2. You can say 15% making purchase beginning of month and 20% the whole month. So what is the probability of making purchase during the month after the month begin? So now we want the probability not in the beginning of month and not the whole month, but during the months after the month begin, which is not mentioned. So in the solution, let A the event of making purchase at the beginning of month, and B the event of making purchase after the beginning of month till the end. Okay, so event B is not mentioned. We want to get the event B. Their union now, the union of A and B, so a union of making purchase at the beginning of month, union making purchase the whole month, after the beginning of month till the month's end will be making purchase the whole month. Okay, so A union B means making purchase the whole month. Since A and B are mutually exclusive, no basic outcomes between them, then their union is simply the total of them or their summation. So the probability of A based on the example is 0.15. The probability of A union B is 0.2. So probability of A union B equals probability of A plus probability of B. So probability of B will simply be the probability of A union B minus probability of A. So 0.2 minus 0.15 equals 0.05. So it's 5%. For example 2, past records show that the international exhibition in one country receives 50,000 visitors, and 500 of them spent $100,000, which is high category, and 2,000 of them spent $50,000, and 10,000 spent $100,000, which is low category. Okay? So now, based on this, say historical data, if this exhibition is receiving like say 50,000 customers or visitors, 500 out of these 50,000 are spending like around $100,000. So this is considered as high category. And 2,000 of them like spending 50,000 out. So this is considered medium category or mid. And 10,000 are spending 100,000, which is low category. If one company wants to prepare a welcome gift for the visitors, what is the probability that this visitor will be from the high category? And what is the probability that this welcome gift will result in any sale? And what is the probability that this gift will result in no sale? Look at the solution now. Let A, the event of high sale, B, the event of mid sale, C, the event of low sale, and D, the event of no sale. The probability of A equals the total number of visitors who are spending high category, which is 500 visitors, divided by the total number of visitors, which is 50,000. So this is 1%. Probability of B is 2,000 divided by 50,000, which is 4%. The probability of C, low category, 10,000 divided by 50,000, which is 20%. The number of visitors with no sale equals 50,000 minus, if we subtract all the visitors who are paying from the total number of visitors, we will get the number of visitors who did not, for example, make any sale or purchase. So if 50,000 minus 500 and 2,000 and 10,000 means 50,000 minus 12,500 equals 37,500. So the probability of D for no sale is 0.75. So now the probability that the visitor will be from the high sale category equals 1% according to PA, and the probability that the gift will result in any sale, as you see that we have probability of A and B and C. So when we talk about any sale, it means that A union B union C. That will mean any of these events means same. So it is 1% plus 4% plus 20% equals 25%. And the probability that the gift will result in no sale, which is 75%, based on the number of visitors who did not make any purchase. Okay, look at the union rule now. If the events are not mutually exclusive, if there is a common basic outcomes between events, it means that they are not mutually exclusive. Then their union will be their summation minus the intersection. So the probability of A union B in this example or in this situation is there are common basic outcomes. They are not mutually exclusive. So it is probability of A plus probability of B minus probability of A intersection B. Okay, so look at this example. If there are 30 students registered in math, 50 registered in English, and 30 students registered in math, 50 registered in English, 25 in English and math, and 70 in other subjects. If you pick student randomly, what is the probability that this student registered in math or English? So the solution that let M the event of register in math, E the event of register in English, O the event of other subject, and S is the sample space. So since M and E are not mutually exclusive, the M event is what? Is students register in math, and E is students register in English. You see that there are students registering in both of them. So that's why this event is not mutually exclusive. So we will get first the probability of M for the English equals 30. The number of students registered in math is 30 students. That means math only. Divided by the total number of students, which is 150, equals 1 divided by 5. The probability of E, which is how many students registered in English, 50 divided by total number of students, this is 1 divided by 3, 1/3. The probability of M intersection E, which is the number of students who registered in both of them, that equals 25 divided by 150 equals 1 divided by 6 or 1/6. So since M and E are not mutually exclusive and their intersection between them, and there is an intersection between them, then the probability of M union B equals PM plus PE minus PM intersection E. So that equals 1/5 plus 1/3 minus 1/6. Using Excel, you can directly get the result as you see here. So it is 0.37. The other part of the question, what is the probability of the student does not register in math? Okay, if the probability of M, which is student registered in math, is 0.15, which is 1 divided by 5, so notice Sorry, there is some mistyping in this example. The probability of M one divided by 5, which is 20%. This is 20%. Sorry for this mistyping. It is not 0.5. It is 1 divided by 5, okay, which is 20%. Yeah. So the rest is okay. So now the probability of M, the students who registered in math, that is 1 divided by 5. So that means that the probability of the students did not register in math, that will be the complement of this event, which is 1 minus 1, 5 equals 4 divided by 5 equals 80%. And this is the probability of the students who did not register in math only. It is not covering those who registered in math and English. Now let us look at the complement rule. The complement rule is, let A be the event, an event, and S is the sample space. All possible results that are not in A and within the S sample space is called the A complement. So A complement equals 1 minus A, 1 minus P A. It means that the probability of A complement means 1 minus the probability of A. So why we are subtracting from 1? Because as a rule in probability, all probabilities must be between 0 and 1. So 0 means impossible and 1 means 100% certain. Normally, probability is between 0 and 1. So for example, if the records show that for each 100 visitor to the showroom, there is number of 5 visitors turn into customers and purchase. If you pick one visitor by chance, what is the probability that this visitor will not purchase? So as a solution, let A, the event of purchasing by the visitor, which equals 5 divided by 100, means 5%. So the A complement, the probability of A complement equals 1 minus probability of A equals 1 minus 5% equals 95%. Now let us see the intersection rule. Intersection A, intersection B means the A and B are happening at the same time. So there is a common basic outcomes between A and B, which is called the intersection. So this part of event or these basic outcomes which is happening in A and B at the same time is called A intersection B. So we have two situations. If the events are independent or if the events are dependent. So if the events are independent, means that occurrence of one event does not affect the other event, then the intersection rule means their multiplication simply. So A intersection B equals P A intersection B equals probability of A multiplied by probability of B. If the events are dependent, that is the case of conditional probability, then we will apply the conditional probability formula, which is the probability of A intersection B equals probability of A given B. This is called probability of A given B. It means that event A is considered to be occurred given that probability B, event B has occurred. That is multiplied by, so probability A given B multiplied by probability B, or probability A intersection B equals probability B given A multiplied by probability A. Let us have a look to this example. You have 3 boxes. Each box contains 5 balls with different colors. So now, if we have 3 boxes and for each box we have 5 balls with different colors, then these 5 balls are blue, yellow, red, black, and gray. If you pick randomly 2 balls from 2 boxes, so now imagine that you open 2 boxes and you simply picked randomly ball from here and from here. What is the probability that the picked balls are red? So let us look at the solution for this. And number 2, if you pick randomly 3 balls from 3 boxes, what is the probability that these balls are green? So look at the solution. Let A, the event of selecting red ball from the first box, B, the event of selecting red ball from the second box. Since the 2 events are independent, then probability of A equals 1/5, because we have 1 ball out of 5 balls. The probability of B equals 1/5 as well. So the probability of A intersection B equals the probability of A multiplied by probability of B, that equals 1 divided by 5 times 1 divided by 5, as you see here using Excel, equals 1 divided by 5 times 1 divided by 5. The result is 4%. So this is the solution of number 1. So let us look at example 2. You have 1 box contains 3 red balls, 4 blue balls, 3 yellow balls. So we have in this box 10 balls. If you pick randomly 1 ball from the box, what is the probability that the picked ball is red? Number 2, if you pick randomly 2 balls from the box, what is the probability that these balls are blue? Okay, look at the solution. Let A, for number 1, let A be the event of selecting red ball from the box. Now, we have 3 red balls out of 10. So, the probability of A equals 3 divided by 10. Let A be the event of selecting the first ball. So now the solution of the number 1 is, as you see here, 3 out of 10, means 30%. So 30% is the probability of selecting red ball from the box. As we have 3 red balls and the total number of balls in the box is 10, so it is simply 3 out of 10. This is classical probability. Number 2, we will apply the intersection rule. If you pick randomly 2 balls from the box, what is the probability that these balls are blue? Here we have to stop because it is not straight question. Look at here, Let A be the event of selecting the first ball, B the event of selecting the second blue ball. So A is the event of selecting the first blue ball, B the event of selecting the second blue ball. So now we will apply the conditional probability rule as B given A means the second ball probability depends on the first ball. It has to be blue first. So probability of A equals 4 divided by 10. And if we picked one ball from the box, then the number of balls for the second ball will be reduced by 1. So the total number will be 10 minus 1 equals 9, and the number of available blue balls will be 4 minus 1 equals 3. So the probability of B given A equals 3 divided by 9. So finally the probability of A intersection B equals probability of B given A multiplied by probability of A, that equals around 13%. Wassalamu alaikum.